This video is to show you how you can do various things with your graphics calculator when you're solving problems using trig graphs. So the first obvious step is that you need to be in the graphs mode on your calculator. So you can do that by either moving your cursor to the graphing section or pressing the number 5 on the calculator. Now you need to check a couple of things. Firstly, that you have nothing on the screen, but also that you are in the right type of function. So you need to have the y1, y2, y3, etc. If it says something different, you can press F3, which will bring you the type button, and then you can change it to make sure that it's just say y equals. If you've got any functions in there, you can press F2 and then delete anything that's there. So I've started by typing off a function here that's going to help me solve a problem of 2 sine x minus 7 plus 5 on my calculator, and I'm going to draw a graph to see what it looks like. Now first of all, that you'll notice that the function looks like it's in radians rather than degrees because of the small numbers, so I need to make sure I change my calculator to set to be radians. Generally any trig function problem is going to be modelling using radians. To do this, I need to change the setup of my calculator, so I need to press Shift and Menu, which takes me into the setup mode. Then I'll see this screen over here. By using the button here, I can scroll down until I find the angle setup, and I want to make sure that it's in radians. If it's in anything different, I can press F2, which will then change it into radians. So that gets me set up for modelling. So now back to my graphing function screen, I can draw the graph by pressing one of two things. I can either press the F6 button, which is to draw, or press the execute button, and that'll draw the graph. On the right, you can see what it looks like when I first draw the graph. Now clearly there's something going wrong here because I can't see my function. Now when you first draw a graph, by hand, what you would do is set up your x and your y axis, and it's exactly the same on a graphics calculator. You need to tell the calculator what you want the range and the domain of the function to be. So you need to think about your x-axis, which in this case is representing time for my function, and the y-axis, which for me is representing the height. The way I go about changing that is by using the view window, which is F3 on my calculator. So as you can see here, what I've done is I've changed some of the things in the view window. The only things you need to worry about is the x minimum, x maximum, y minimum and y maximum. The scale and the dot is just some functions that are where the pictures are on the graph, and you don't need to worry about that. So for me, I'm looking at a function which is about the height of a Ferris wheel. So my x-axis is time. So I'm obviously going to start with 0 because I don't want negative time. And for this particular question, it's in minutes, and I'm going up to 12 minutes to cover what's needed in the question. So my maximum is 12. The y is the height of my Ferris wheel, so I'm going to start with 0 at ground level. And then to find the maximum, I look at my function of my graph. I can see on my graph that plus 5 means that the whole thing has shifted up 5. And also the 2 here tells me an amplitude of 2. So that tells me that the maximum height I need for my graph is 7. So I've put in 8 just to give myself enough space, and I can see the whole function. So now I can see what the graph looks like when I draw it. Much better, I can see it's a trig function. So now there's various things I can do with this, and the key button here is the F5 button, G-solve. The G-solve button does all sorts of things for you. You can see the menu I've got here. The root of the equation is where the graph will cross the x-axis, which is not relevant for this problem. Maximum and minimum tells me the coordinates of a maximum point and a minimum point. Y-intercept will tell me where it crosses the y-axis. Intersection tells me where, if I had another function on the graph as well, the two things meet. So if, for example, I press the maximum button, you can see here that what it shows you is it moves the cursor to the point where it's the maximum of the graph. And I can see that that maximum is 7, which I predicted, at an x-coordinate of 2.288 minutes into my graph, remembering I'm working in minutes. If I use this button and press the right-hand side of it, the cursor will move to the next place where there is a maximum and tell me the coordinates of that point too. I can do exactly the same thing with the minimum. Now those other functions on the calculator, if I was to press F6, you'll see I get 3 other options here. The 2 we're going to look at are the y-calc and the x-calc. Y-calc is if I'm looking for a y value with a given x coordinate, and x-calc is if I'm looking for a given x value looking for an x value for a given y coordinate, and I'll show you how those work. So say for example for a y calculation, a question might be asking me how high is the roller coaster after 2 minutes? So for that, I'm going to press the Y calc, and what I get here is a question asking me to enter an X value. So I want to know when the time is 2 minutes, so that X equals 2. If I enter that into the calculator, it will move the cursor onto the graph to the point when the time is equal to 2, the X coordinate is 2, and it tells me that the height at that point is 6.92 metres above the ground. If I do the same thing with xcalc, that gives me the x values for any given y. So let's say, for example, the question asked you when is E 6 metres above the ground. So for this, I'm putting in a y coordinate of 6 for 6 metres above the ground, and when I draw the graph, it gives me the first point here when the y coordinate is 6, and that tells me that after 1.24 minutes, he is 6 metres above the ground. If I use my right button on here again, the cursor will move and tell me the next time when he is 6 minutes above the ground, and so on. I can continue that as many times as I need throughout the whole graph. The problem I'm looking at here, I've actually got two different Ferris wheels, so I've got a second function to put in. So you can see here under y2, I've put in the second function, and I've written it exactly like it's written on the question. So y equals cos 2 bracket x minus 5 close bracket plus 3. Looking on the right here, you can see that it maybe doesn't look quite right. It's a straight line. I'm expecting a cos function, so I'm expecting it to look more like a cos curve, and it doesn't, which suggests I've done something wrong. And this is something you need to be aware of when you're putting functions into your calculator. You need a bracket as soon as you've used cos or sine, which suggests that I need to put an extra set of brackets in my function around here so that it understands. Okay, so here you can see the function now with the extra set of brackets in here, and what it looks like on the graph, much more like a trig function. Now I can use this to help me find various things. For example, the question I'm looking at asks me how long during the 12-minute ride is the smaller Ferris wheel higher than the larger Ferris wheel. So looking at my graph, I'm looking at the parts of the function here. Sorry, I'm looking at the parts of the function here and here, where it's higher. So to be able to find those, I need to find the point of intersection of the two curves. Again, I can use the F5 gsolve function and then the intersection button. Okay, so using the intersection button, F5, I can see the first point of intersection here is given to me as having a time of 4.584 minutes into the function. If I press the right hand button again, it will move over and tell me the next point. And the next point you can see is at 5.738 minutes into the function. The other important thing to note at this point, obviously, is that my function is cyclical. So this point here is repeated over here. So once I know the time frame that it's taken between these 2 points, I can just double it because it's happened twice. So now I know that this point here is at 4.58 minutes, and this is at 5.74 minutes. I can find the time difference between them. 5.738 minus 4.584 gives me 1.15 minutes. So at 1.15 minutes is the time taken when the second Ferris wheel is higher than the first. If you wanted to, you can also convert that into minutes and seconds, which would be 1 minute and 9 seconds, remembering to double that because it's happening twice. So hopefully that's told you all sorts of bits and pieces that you can do with your calculator, and you can always play through to find some more.